Hi, and welcome to this section of the course where we're going to talk about word problems that involve subtraction of decimals, okay? So we've done addition, subtraction, multiplication, and division of whole numbers, and then we've done addition of decimals, and now we're going to do subtraction of decimals. And this section of the course is very similar to the section on subtraction of whole numbers. So the logic's going to be the same, the motions are going to be the same. The only difference between this section and the section on subtraction of whole numbers is going to be the numbers in these problems are going to have decimal points in them. So that's the only difference. So if you haven't watched the section on subtraction of decimals, go ahead and do that now. I'm sorry, subtraction of whole numbers, go ahead and do that now, and then come back to this section, and this will be as easy as pie, and we'll get some practice with the math. So recalling from that section on subtraction of whole numbers, remember that subtraction problems in general pretty much need you to compare two numbers. That's what's going on here. You're usually asked to find what is the difference between this person's age and that person's age, or how much older is this person than that person, how much taller is this person than this person, how much longer is the table than a car, how much shorter is a chipmunk from a polar bear. I mean, things like that. So you're usually asked to find how much taller, how much shorter, how much longer, how much shorter, how much older, how much younger, things like this. So anytime you have something that involves comparing two numbers like that, when you're trying to find out how much bigger or smaller or something like this, you're usually going to subtract those numbers, okay? So let's go ahead and work some problems in this section, and they're going to all involve decimals, and we'll get some practice with that. The first problem says, yesterday at noon, the temperature was 78.3 degrees. Today at noon, the temperature is 67.1 degrees. How much higher was the temperature yesterday than today? So you see, this problem has all the elements we just talked about. You have a temperature yesterday given to you, 78.3, and today the temperature is cooler at 67.1. And you're asked how much higher. See, that's what I was saying. How much higher, how much lower, how much shorter, how much longer. This one is how much higher was the temperature yesterday than today. Okay, so what we're doing is we're comparing these two numbers, and we need to subtract them to find the difference between them, and that's going to tell us how much higher the temperature was. Okay, so writing that down, it was 78.3 degrees yesterday, and I'm just going to write that down as a note to myself because you know, paper is cheap, and it's good to go ahead and remind yourself what you're talking about. And today is 67.1 degrees. Okay, and these are both degrees. Now remember, in other parts of the class I've always told you, when you add or subtract numbers together, you have to have the same units. So we have the same units. Degrees subtracted from degrees is going to give us degrees in the final answer here. Okay, so we want to subtract these things. Working in this column first. 3 minus 1, I think you can convince yourself is going to be 2. 3 minus 1 is going to be 2. Now the nice thing about subtracting decimals, you notice when we wrote the problem, you always have to line up your two decimals on top of each other. You always have to do that. When you add them and when you subtract them, the two decimal points should be right on top of each other. And the nice thing about it is when you write your answer down, the decimal point just comes right on down. It just falls right on down to the bottom. So you don't really have to do any thinking on the decimal point. You just put the decimal point right where it sits. Okay? So let's move on to this column. 8 minus 7, I think you can all convince yourself is 1. 8 minus 7 is 1. And 7 minus 6, I think you can all convince yourself is 1. So you see, the answer is 11.2, what? 11.2 degrees. Okay, so if you were going to write this down in words, you would say, yesterday was 11.2 degrees hotter than today. So basically what you've done is you found, you know, here is yesterday up here at 78.3, right? And today is over here, and this is today is like 67.1. So what you've done, and this is the temperature here, what you've done by subtracting them is you found out how much hotter it was. What is this distance here? How much hotter was yesterday than today? was 11.2 degrees hotter, or 11.2 degrees higher. Okay, so you're comparing two numbers together, and and so you have to use your subtraction. So the next problem is going to be similar, and it goes like this. On Wednesday, you mow a lawn, and it takes 1.7 hours. On Thursday, you mow a lawn, and it takes 2.3 hours. How much longer did it take on Thursday than Wednesday? So you see it's the same thing. Reading it again. On Wednesday, you mow a lawn, it takes 1.7 hours. Okay? On Thursday, you mow it, and it takes 2.3 hours, so it actually takes longer to mow it. How much longer did it take on Thursday than Wednesday? So same thing. That last sentence tells you how much longer did it take. You know you're not going to add these two numbers together, okay? Because that would just be silly. If you add these numbers together, you're finding the total amount of time I mowed the lawn on both days. But that's not what this is. You have to understand what the problem is asking you. This problem says how much longer did it take on one day than the other. So it's asking how much longer were you out there, okay, on one day than the other. And so in order to find the difference there between the 2 days, you have to subtract these numbers together. So if you were going to do that, on Thursday it took 2.3, and 2.3 what? You always have to ask yourself. It took 2.3 hours, and that was on Thursday. And that's straight from the problem, okay? And it says on Wednesday it takes 1.7, again, hours, and that was on Wednesday. Okay, 1.7. And notice I wrote them with the decimal point right on top of the other. You always have to do that. Okay, we're going to subtract these two numbers, and we're going to find the difference between these two times, because that will tell us how much longer it took on one day than the other day. Okay, so working in the right-hand column first thing we have to do is take 3 minus 7, and you know that you can't really do that because 3 is smaller than 7, so we have to borrow. Okay, so the way you do that, and we've talked about this before, is you just put a little 1 up here, making it a 13, but this has to come from somewhere. You can't just make it up out of nowhere, so you take it from the 2. You scratch through the 2, and you put a 1 here. Okay, so the 2 becomes a 1 because I'm borrowing, and I'm giving that 10 that I borrowed from here, I'm giving that to the 3 there, making it a 13. Okay, so basically you take it, subtract 1 here, make this a 1, and add it over here, making this a 13, is what you're doing, okay? So now you have 13 minus 7 instead of 3 minus 7, so that's doable, okay? Starting at 13 and subtracting 7, starting at 13, 12, 11, 10, 9, 8, 7, 6. So the answer is 6 because I subtracted 7, so the answer is 6. So put a 6 there. The decimal point just falls right on down just like it always has. It's really easy in these subtraction and addition problems. And now you have 1 minus 1, which gives you 0. Because once you scratch through this 2 and do the borrowing business, the 2 is gone from the problem. He is not part of anything anymore. He is gone. That's why you put a line through it. So it's 1 minus 1 gives you 0. So the answer is 0.6 hours. Okay? So the way you would say this in words is you would say Thursday, which is this day here where it took longer. Thursday took 0.6 hours longer to mow the lawn than on Wednesday. That's how you would say that. So you found exactly what the problem was asking. You found out how much longer it took you on Thursday than it did on Wednesday. Maybe on Thursday you were more tired. Maybe on Thursday you were just playing lazy. Who knows why? But it took longer on Thursday, and it took 0.6 hours longer, which is just a little bit more than 0.5 or half of an hour. So it took you a little bit more than half an hour to finish mowing the lawn on Thursday. The next problem says, a table measures 7.3 feet long. A chair measures 2.1 feet long. How much longer is the table than the chair? Okay, so you have a table that's pretty long, 7.3 feet long, and you have a chair that's much smaller, and the chair is 2.1 feet long. So the table's obviously longer than the chair, and the problem says how much longer is the table than the chair? So you have the same keyword. How much longer, how much shorter, how much older, how much younger, things like that. It applies to subtraction. So you're going to have to find out how much longer is the table than the chair. So basically, if you were going to draw some kind of picture, if this were the table here, then you could say that this was something like this was like 7.3 feet. That would be like the length of this table. And you have a little chair here, which is, I'm just going to draw as a little square. And this chair is 2.1 feet long, okay? So the table is this long and the chair is this long, and the only thing you're asked to do is find out how much longer is the table. So what you want to know is how much longer is the table than the chair. So you want to know this distance, okay? So because you're trying to find out how much longer it is, you just subtract these numbers. So basically you're taking this distance and you're subtracting it off, and so you find this in the end, and that's why you do the subtraction. That's why you're not doing addition or multiplication or division. Okay, that's why you're doing subtraction, because you're trying to find out how much longer. So you want to subtract this part off. Okay, so the table is 7.3 feet, and that's the table. Okay, I always write my units down because it helps me remember what I'm doing. Okay, the chair is 2.1. Again, it's feet. Okay, it's supposed to say chair here, okay? And what you want to do is you want to subtract these two, and just to remind you, when you're doing addition and subtraction, the units must be the same. So even though this is tables and chairs, it's 7.3 feet minus 2.1 feet is going to give me some answer in feet. So I have to have the same units, and I do, okay? So subtracting this, starting in the right-hand column, 3 minus 1, I think you can all convince yourself 3 minus 1 gives you 2. So you'll just put a 2 here, okay? This decimal point here, you'll just drop it down and put it right on down there. And notice when I wrote the problem down to begin with, I always line the decimals one on top of another. You always have to do that when you're subtracting or adding decimals. And you just drop it on down. So there's no thinking involved. Okay, now moving to this column, 7 minus 2, starting at 7, 6, 5. So 7 minus 2 is 5. So we have is 5.2, 5.2 what? 5.2 feet. So the way you would say this is, in words, the table, which is this here, is 5.2 feet longer than this little chair here. So the table itself is 7.3 feet long, but it's actually 5.2 feet longer than this little chair here, and that's why you had to do the subtraction. So you subtract this little chair out of here, and then you know how much longer the table actually is. Okay, now the next problem is a little bit different. It's a great problem, though, because it's kind of like real life, something you might have to do in real life, and it goes like this. A pair of shoes costs $19.95, and a pair of socks costs $2.95. You give the cashier $30. How much change do you get? Okay, in other words, how much change does the cashier give back to you? And you put it in your wallet, your purse, and you go on. Okay, so you have to think about this a little bit because there's three numbers in this problem. There's the $19.95, there's the $2.95, and there's the $30. And if you don't really understand what this problem is asking you to do, you're going to start, a lot of people just start working problems and they start doing things with numbers without really knowing what they're supposed to do and just hoping that they get the answer right. You must understand what the problem is asking you to do, and then you'll know what to do and make your life easy. So let's read it again. Shoes cost $19.95. Socks cost $2.95. Okay, you give the cashier $30. How much change do you get? Okay, so I think the first thing we need to do is we're going to pay for both of these items, so we need to know how much money these items are going to cost together, the socks and the shoes. So the first step will be to add up the socks and the shoes, the cost, okay, and we'll get some number. And that's how much money we actually owe the cashier. And then when we give her $30, if we subtract the $30 from the total amount of everything that we purchased, we will get our change back. Because that's the definition of change. You go to the store and you buy a pumpkin, okay, and you give them $10 and the pumpkin costs $5. Well, I gave her $10, I overpaid, so I subtract in order to find out how much change I get back from the cashier. That's what change is. In this case, I'm buying two items, so the only difference is I need to just add them up first, and then I'll find out how much change I get. So let's go ahead and do this. Let's find the total cost of the socks and the shoes together. Okay? The total cost of the socks and the shoes, we said it was $19.95, and that was for the shoes. Okay? And it was $2.95 for the socks. Okay? And I'm going to put a little dollar sign here because we are dealing with dollars. So what we're doing, even though it's shoes and socks, we're adding dollars to dollars, okay, is what we're doing. And so we're going to end up with dollars. Dollars to dollars gives you dollars, you know, and that's what we need to have here, okay? So let's add this up. We'll start in the right-hand column. And one more thing I want to mention. I always line up these decimal points. I keep saying it over and over. I had to push the $2.95 over to the right because I could have written it here, 2.95 or something like this. I could have put 2.95, but that would be wrong because the decimal points have to be right on top of each other. So even if you have to scoot one of the numbers over to the right, go ahead and do it just to make sure these decimals are on top of each other, okay? So starting with this column over here, 5 plus 5, I think you all know is 10, okay? And if you don't, you can start at 5 and continue counting. 6, 7, 8, 9, 10, okay? So 5 plus 5 is 10. So I need to write a 10 down, but I'm not going to write it down here. I'm going to put the 0 here, carry the 1 to the next column. When you're writing two digits like this, and you're adding, you need to put the right-hand digit down and carry the next digit over to the next column, okay? All right, now moving on to this column here. 9 plus 9 plus 1, what does that give me? Well, there's a couple ways you can do this. You can start using your fingers, but there's an easy way. Notice this. 9 plus 1 gives you 10. That's something I think everybody knows. 9 plus 1 gives you 10. And then 10 plus 9 more down here gives you 19. So we know the answer is 19. 9 plus 1 gives you 10. 10 plus 9 gives you 19 because starting at 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I added 9 more and got 19. But again, I don't want to write 19 down here with the 1 and a 9. I'm going to put the 9 here, carry the 1. Okay? So you're always going to be doing this in your subtraction problems. Put a 9 there, carry the 1. Okay? Now, these two decimals are on top of each other and it just falls right on down. That's why we do that. Now let's go and add this column up, and we're going to do the same little thing. 9 plus 1 gives us 10, plus 2 more gives us 12. Okay, so think about that again. 9 plus 1 gives us 10, and then 10 plus this 2 down here gives us 11, 12. So we add 2, we got 12. But again, I don't want to put 1, 2 down here for 12. I'm just going to put the 2, carry the 1, because I'm writing 12 down like this. Okay, now we have one more column of numbers to do, which is this one. 1 plus 1 gives us 2. Okay. So you see, now we arrived at $22.90. And you always need to make sure, you really always need to think about, does this make any sense at all? Okay, before you go on. Okay. We had some shoes that cost almost $20, $19.95. And we had some socks that cost $2.95. It's almost $3. So when you add them up, you know that it's going to become pretty close to $23 because this is just about $20 and this is about $3, so it should be about $23. Well, we got an answer of $22.90, which somewhat makes sense. So you always should look at your math and make sure that what you're doing actually makes sense, okay? So what we found is this number right here is cost of shoes plus socks. Okay, $22.90. But we're handing the cashier $30. And we want to know, because the problem says, how much change should you get? So when we give her $30, if we subtract off the $22.90 that we actually owe her, then the difference between those two should be the amount of change she hands me back, $22.90. Anytime you're asked to find change, you're going to have to subtract something. You're going to have to subtract how much you give her or him from how much you actually owe them, because that's how much stuff you bought. Okay? So all we have to do is subtract these two numbers here, and then we know how much change we'll get back. Okay? Notice I line the decimals on top of each other. That's very important. Okay? Now let's go over to the right-hand column here. 0 minus 0. Okay, that one's easy. 0 minus 0 gives you 0. Now here's where the fun starts with this one, because you have 0 minus 9, and you know you really can't do that because 0 is less than 9. I mean, 0 is nothing, so how can you subtract 9 from it? Well, you need to start borrowing. So what we're going to do is we're going to put a 1 here, making this a 10, so that now we can do the subtraction, but we have to get it from somewhere, and we're going to try to get it from this guy. But how can we get it from him? Because he's 0 too. So how can we borrow something from somebody that has 0? Well, what we're going to do is we're going to do that just like this. We're going to make him a 10, okay? And we're going to make him a 10 by making this 3 a 2, okay? And then we're going to scratch out through this 10 and we're going to make him a 9. Now I need to explain this because this is complicated stuff, okay? We had to borrow 2 times. Actually, we had to borrow 3 times, okay? No, we had to borrow 2 times. We had to borrow from him and we had to borrow from him, okay? Now usually when you borrow, you'll make him like a 10, for instance. You'll put a 1 there and you'll make him whatever. And you'll borrow from the next column. You know, and if this were a 2 or a 3 or a 4, we would have just scratched through it and we would have made it a, you know, the 1 number less, just like we did in the problem before, okay? But he's 0. So we can't really do that. So what we do is we make him a 10 and we borrow from him, making him a 9. But in order to make him a 10 in the first place, we have to borrow from the next column over. So you see what we're doing is we're borrowing from him and we're borrowing from him, making him a 10, but then we immediately scratch through him, making him a 9 so that we can borrow, okay? Just think about that for a little bit and try to convince yourself, and I'll just kind of go through it just one more quick time. We had to borrow to make him a 10. So we tried to borrow from him, but we couldn't because he was 0. So we made him a 10 by borrowing from the 3, and then as soon as we made him a 10, we immediately borrowed from him because we had to give him the 1. So we made him a 10 and then made him a 9 in order to do that. And it was all kind of complicated just because this guy was a 0 to begin with. So you had to make him a 10 in order to borrow from him. And we had to make him a 2 in order to make him a 10, if that makes any sense, okay? So you'll have to do this a lot. Anytime you have a lot of zeros together and you have to start borrowing, this is going to be something you're going to do a lot. Basically, you'll have to borrow from the next guy and the next guy. You'll have to keep borrowing until you finally hit a number, okay? And making everybody 10 until you hit a number. And then once you make everybody 10, then you can borrow as you need to, okay? So going to this column, finally, 10 minus 9 gives us 1, okay? The decimal point just falls right on down just like it always does. And now you see we can do this subtraction because 9 minus 2 is going to give us 7, starting at 9, 8, 7, okay? It's going to be a 7. And now finally 2 minus 2 gives us 0, so we don't really even have to write anything. So you're going to get $7.10 in change, okay? $7.10 in change. So that's how much change you would expect to get back. So this problem was similar to the rest. The only two gotchas is we had to add up the total costs of the socks and the shoes together, okay? And we had to do some borrowing there to get the total cost here. And then when we subtracted from the 30, it was a little bit tricky because there were so many zeros here, because you have to borrow, you want to borrow from the 0, but you can't do it because he's 0, so you have to make him a 10 in order to borrow from him. In order to make him a 10, you have to borrow from the next guy. So what you end up doing is borrowing until you finally hit a number, and then you can stop borrowing, and then you can go and do your subtraction. Okay, the next problem says you pour 3.4 ounces of water into a glass, and later you pour an additional 1.7 ounces into the glass. Okay, your sister then takes the glass and dumps out 2.1 ounces onto the floor, and the question is how much water remains in the glass, okay? Let's read it one more time because there's, again, 3 numbers here, so we need to make sure we understand. You have a glass, we pour some amount of water into it, 3.4 ounces into the glass, and then someone else later pours more water into it, 1.7 ounces, and then, so now we have some water in this glass, and then somebody comes along and pours out some water, 2.1 ounces onto the floor, and how much is left? That's what we have to do. So this problem is going to involve addition and subtraction because the first thing we see, we add some water to it, 3.4 ounces, and then we add some more water to it. So we want to add those two amounts together to find out how much water was in the glass. Okay? And then we pour out 2.1 ounces to find out, and we do subtraction there to find out how much water remains in the glass. Okay? So let's go ahead and look at a picture. I think pictures help. Okay? So what we're going to do is we start with an empty glass. It's always important to understand what's going on. So we start with an empty glass. The next thing that happens is we pour in 3.4 ounces. Okay, so I'm going to put a little, I guess a little line like this. So we put 3.4 ounces. Okay, we add that into the glass, so I put a plus there. Okay. Then later on in the day, someone comes along, and we had this much water there, but now the water is higher because somebody added 1.7 ounces. And that's what the plus 1.7 ounces. Somebody poured water in, and then somebody poured even more water in. They added some more water, so now the water level is higher, okay? And then later, even after that, somebody takes this glass that has this much water in it, and they pour it out. And they subtract out minus 2.1 ounces. So they pour some water out, so then the water level drops back down to here, something like this. And the question is, how much water is left? Okay, so I drew it like this on purpose to show you what's going on. You have an empty glass, put 3.4 ounces in, add another 1.7 ounces, and then subtract out 2.1 ounces because you pour it out. That means you subtract it out, and then whatever's left over is going to be the answer. Okay, so let's do that. Let's say you're adding 3.4 ounces to 1.7, and these are ounces of water. You're adding these in. So let's do that first. We're going to add these two first, and then when we get the answer, we're going to subtract off however much we poured out. And then we're going to have as an answer what remained in the bottom. Okay. So starting in the right-hand column, 7 plus 4, starting at 7, 8, 9, 10, 11. Okay, so that's going to be 11, but we can't just write 11 down here. We put a 1 and we carry the 1, okay, to the next column. The decimal points we always put on top of each other, and it just falls right on through, and now we can work on this column here. 3 plus 1 is 4, plus 1 more is 5. So this will just be a simple 5. 5.1, and again, it's ounces because ounces plus ounces gives us ounces. The units are the same. So when we added all of this water in up to this point, now we have 5.1 ounces in the cup. That's how much water is here, 5.1 ounces. And now we subtract off 2.1 ounces, we pour some out, and whatever remains at the end will be what we have left. So we're going to subtract off 2.1, again, ounces of water. Okay, we're going to start at the right-hand column. We lined our decimals up. We're going to start at the right-hand column. 1 minus 1 gives me 0. Okay, decimal point just comes right on down. Nothing too fancy there. And then working in this column, 5 minus 2, we're going to subtract off starting at 5, 4, 3. Okay, so that's going to be 3. So 3.0 what? 3.0 ounces, or simply 3 ounces, 3.0 or 3 ounces, same thing, of water remains. So you would say on your problem, 3 ounces or 3.0 ounces of water remains. So we start with a glass, we add some water to it, we add some more water to it, and we pour some water out. So we're adding, and then we're subtracting, and then we finally have this much water that remains in the glass. Okay, we're making some good progress here. We're getting into some more complicated problems with 2 and 3 numbers, and where we have to do some adding and some subtracting. That's why it's very important to draw pictures when you can, and also just make sure you understand the problem. It's very easy to look at 3 numbers and really not know what the problem's asking you, and then just start doing stuff with the numbers, not really knowing what you're doing, and then you get the wrong answer, and then you get frustrated. Just read the problem, get some practice by working through these, and then that way next time you work a problem yourself, you'll know what to do, and it'll make it easy, okay? So the next problem says, 1.3 cups of cake batter expands in the oven after you bake it to a volume of 4.8 cups. Okay, how much more volume does the cake occupy than the batter? So this problem has some complicated sounding words. I mean, you're talking about volume and expanding and things like this. It's very simple. When you make a cake, you pour this stuff in a bowl, makes a batter. You mix it up, and it makes this slushy looking batter. You pour it in a pan, and the batter is, maybe this much, and you put it in there, and the cake gets bigger in the oven. We say that it expands. That's what that means, okay? So it goes in the oven, the cake gets bigger, it starts to puff out, starts to get nice and fluffy. So the cake itself, when you pull it out of the oven, is bigger than the batter that you put into the oven. And that's just because the eggs and the flour and everything in the oven, it makes it get bigger and nice and fluffy and yummy, okay? So it expands. So this problem is saying that the cake batter that I put into the pan was 1.3 cups. But when I put the cake out of the oven, the cake actually had a volume, or a, just kind of a size of 4.8 cups. So it was bigger, which makes sense. And then the problem says, how much more volume does the cake occupy than the batter? So it's one of the subtraction problems. How much more? How much more volume? Okay. So we need to subtract the volume of the cake from the volume of the cake batter to find out the answer to the question. So 4.8 what? It's 4.8 cups. Okay, and we're subtracting off 1.3 cups. Okay, now this is the cake after we pull it out of the oven, and this is the batter that we put in there. So we're taking the volume, or the volume of the cake here, and we're subtracting off the volume, and that is going to tell us how much more volume does the cake occupy than the batter. Again, I align the decimals one on top of another, starting in the right-hand column. 8 minus 3, let's start at 8, 7, 6, 5. Okay, so we got 5. Decimal point just comes down, drops on down. Now working with this column, 4 minus 1 gives me 3. So now we have 3.5, that's the answer. 3.5 what? 3.5 cups. So you would say in words that the cake was 3.5 cups more volume than the batter. Volume is just a big word that just means size, basically. You know, something has more volume than something else. It just means it occupies more space. Okay, so the cake occupies 3.5 cups more space than the batter did. Okay. Okay, our final problem in this section goes like this. Jake is 27.4 years old and Jenny is 45.1 years old. How much older is Jenny than Jake? Okay, so we have two people. Jake is 27.4 years old. Jenny is 45.1 years old. How much older is Jenny? Same thing. You have a nice key phrase. How much older is Jenny? You know, subtraction problems are how much older, how much younger, how much bigger, how much smaller, how much longer, how much shorter, things like this. So you know you're going to have to subtract because you're trying to find out how much older she is. So you have to subtract their ages to find out how much longer she's been around alive. Okay? So, starting with Jenny's age, 45.1, and what is it? It's years. Okay? 45.1 years minus 27.4 years. Always need to write the units down so we know what we're doing. Years minus years is going to give us years. So that's what we want. Okay? We always line the decimals on top of each other when we're subtracting and adding decimals. So in the right-hand column, what we need to do is we need to subtract 1 minus 4, but we really can't do that because 1 is smaller than 4, so we need to borrow. Okay? So we're going to have to do some more borrowing here. So we'll put a 1 here to make that an 11. Okay? And we will take it from here and make this a 4. Okay? So let's go ahead and do this. 11 minus 4, okay, 11 minus 4, starting at 11. 10, 9, 8, 7. Okay? So that's going to be 7. So right here, 11 minus 4 is going to be 7. The decimal just comes right on down. Now we're doing well. Let's continue on to this column. So now we have 4 minus 7 because we did our borrowing. And again, we can't really do that because 4 is less than 7, so we have to borrow again. See, sometimes you have to borrow more than one time. So what we will do is we'll make this a 14, and we'll steal some money over here from here, making it a 3. So we'll just borrow from the left-hand column there. Okay? Now that this is 14, we can actually do it. 14 minus 7 is going to give us 7. Let's try it out, starting at 14. 13, 12, 11, 10, 9, 8, 7. Okay? So it is going to give us 7. And then working on the left-hand column, 3 minus 2 gives us 1. So 17.7 what? 17.7 years. Okay? So what you're saying is Jenny is 17.7, almost 18. That's what the 0.7 here means. Almost 18 years older than the other person in this problem. So we started on the right hand. We had to borrow. We made this 5 a 4 to borrow. We did the subtraction here. And then when we got to this column, we realized that we couldn't do the subtraction either. So we had to borrow again from the left column, and then we could do the subtraction here, and then we could do the subtraction here, and that's the answer we got. So to summarize, in this course we've done, in this section we've done problems involving subtraction of whole numbers, subtraction of decimals. They're very similar, I mean, in fact they're exactly the same as all of the subtraction problems we've done before, except that the problems have decimals in there. So you just need to line your decimals one on top of another. Start at the right, move your way to the left, doing your subtractions very carefully. And if you have to borrow, just make sure that you do it and borrow from the next column over so that you can actually do your subtraction. And sometimes you'll have to borrow multiple times. You may have to borrow 2 or 3 times, especially if there's a lot of zeros in that top number, and do it that way.